Hello everyone! We would like to introduce an experimental PrusaSlicer fork that allows us to save time and material in multicolor 3D printing. The developing interlayer tool clustering algorithm may significantly reduce production costs, including material, time, and energy, as well as decrease the probability of failure by reducing the number of tool changes. The basic idea is to print as many layers as possible with a single tool until that multi-layer batch reaches the maximum allowable height or critical intersection with the area below. Then change the tool to a new one and repeat this process again until the entire object is finished. This video is a brief walk through the slicing process using the new algorithm. Here is the working repository with examples and added features. It shows brief instructions on using the control elements and demonstrates quality tests, close-up images, and printed samples. It should also be noted that from the beginning of Slick 3R development, a lot of software branches like PrusaSlicer, Bamboo Lab, and OrcaSlicer have been based on the same libslick 3R library, so the presented modifications may also be transferred to other similar solutions. Okay, so let's start with the sample model of the Charmander Pokemon. We choose a small 28mm height size to better show off all the details. So we will start with the default slicing parameters in Prusa for a 5-color extrusion system. Let's hit the slice button and wait for the results. As you can see in the default example, the wipe tower consumes more filament than the object itself. Of course, increasing the number of identical objects in the scene or using the wiping into infill option will improve the ratio between waste and useful material. But still, if you would like to print one small object, manufacturing the material transition tower may take longer than manufacturing the object itself. In this case, we see that the total printing time is 3 hours and 45 minutes, of which you spent more than 2 hours just for generating the wipe tower and 1 hour to move the nozzle to and from the wipe tower. This is all because you must change the material within every single layer. Now let's switch to the interlayer tool clustering method. In this control tab, we have enabled tool clustering, then we have a parameter representing the safe batch height and a parameter representing the maximum allowed color intersection. So we keep the height parameter of 1 mm and the critical intersection of 30 units and slice it again. With the tool clustering method, we don't need to switch tools every single layer. Instead, we are trying to print as many layers as possible using only one tool before switching to another. As we can see, the wipe tower fabrication and travel time are now much shorter. The variable critical intersection parameter allows us to adjust the allowable overlap between already printed areas. We have also added two color sliders to help visualizing the order of printed layer batches and highlight overlapping regions. Now, if we compare the two sliced results side by side, we can see a big difference in both the wiping and traveling time segments. In this specific example, it takes almost half the material and half the time, and therefore energy, to produce the wipe tower using the tool clustering method against the default case. This is also a good example to show that if you change tools quite often, travel time will have a significant impact on the entire fabrication. Minimizing the number of tool changes also reduces the risk of failure in the whole production process.